Okay, hi everybody. So today I'm going to talk about lab on image processing. So we'll begin with this lab exercise. So you're going to open up the training slides. So before this, we go for MATLAB quick start. Now we go for image processing. Okay, under image processing using MATLAB PDF. Okay. And please make sure that you have your MATLAB started. So image processing is a toolbox. Okay, there are many toolboxes under MATLAB. So image processing toolbox is actually a collection of related function for a particular type of application. So in this case, image processing toolbox is actually consists of all the functions used for image processing. Okay, so if you look at the outline, so today I'm going to talk about the first section, which is to work with images in MATLAB. So we're going to talk about the various image types and classes, the data types in MATLAB to represent image, and how do we read and write images, and how do we display image. Okay. All right, so for these sections, we have three. The first one is on the image type. So I'm going to discuss about 4 types. The first one is index, followed by intensity, binary, and RGB. And next, we'll talk about importing and exporting images. So we'll talk about IMF info, which helps you to determine the important info before you could start loading or exporting images. Then we have IM read and IM write. And last, to display IM show. And we also look at various functions to convert between image format. Okay, so there are 4 basic various types of images. So you can see that there are index, intensity, binary. So index image basically consists of a color map. So this is important for you to note because in your lab test, you'll be asked to display both index and non-index image. So they have different ways of handling index and non-index image. Okay, so intensity basically is from range, is basically gray level image where you have like 0 to 255 is integer, or 0 to 1 floating point. Binary, 0 or 1, black and white only, black or white only. And RGB, as you know, we have 3 metrics, the red, green, and blue. So you can actually load the data, the sample images. All right, so let's try to load the image. Load. So as usual, I try to use tab. Okay, so sample images. And if you have not done, you may not be able to see that if you have not done the path setting. So in this case, I have done the path setting. If you have not done this, please do so. So you need to add with subfolders, and then you need to go to where your IP folder is located. So my IP folder here, okay. So we're going to choose this one, your IP folder, notes plus lab, just to let you see clearer. Okay. So IP folder, notes, lab. Okay, so select folder. Okay, and then you will add with subfolders, and all this will be added. Okay, so all the subfolders under lab, okay, will be added. All right, then you save and close. So with that, then you should be able to type halfway sample, and then this should be listed. And you observe that now in your space, you have several 5 variables. So all this actually represents different types of images. Okay, so if you look at their dimension. Okay, you can see that the first one, this one is actually a logical type, so it's true false, and this is unsigned integer 8-bit from 0 to 255. This one too, and for RGB, it's basically 3 matrices. This one double means it's floating point numbers. Okay, so you can display them one after another. Okay, for the data types, as you have seen, is either floating point, double, or it can be integer. Typically, UINT8, unsigned integer 8-bit. Unsigned means no negative, so 0 to 255. If it is 8-bit, 16 bits, then of course, then you have double the precision. Okay, so let's try to IM show index image. Okay, IM show index image. So you need to take note of this. See, when you show IM deal with index image, you need to provide the map as well. Okay. So if you try to use this cursor here and you try to click to select to look at the pixel or one of the points in the image, so you can see, okay, so what is the location X and Y, and then what is the index, okay, and what is the actual RGB. So you see for index image here, what they do is the color is represented by an index, and they need to refer to the map. What is the actual RGB value for this particular index? It's explained in the slide here. So if you have, okay, an index 5, so before they could display the image, they need to go to the map. That's why you need the map. So they need to refer to index 5. Okay, 1, 2, 3, 4, 5. Okay, 5, this is the R, G, and B. So I call it index image. Why they need index image? Because usually in image, you don't have, if you go for RGB 8 bits for R, G, and B, so 24 bits, you can go for 16 million color. But typically image, they will have no more than several hundred colors, so it's a waste if you use 24 bits per pixel. So the thing of a way to do compression, that is to save instead of using 24 bits, since you have less than like a few hundred colors, let's say less than 200 colors, so you need only like 7 bits or 8 bits. So therefore, they say instead of using 24, I use only index, which is 8 bits from 0 to 255, because after all, you know, total colors in my image is less than 200. So then they will, okay, for all the available colors, they will associate with an index. And then instead of the code with the actual color, 24 bits, they put only with the index. So the index will only be 8 bits. So therefore, you save like 16 bits. You use only 8 bits instead of 24 bits. So that's the purpose why there is this index image. But for practical usage, so what you need to know is when you want to handle index image, make sure that you need to have the map. To display, you need to have the map. To read, you need to read the map. And to save also, you need to save the map. All right, so that's index image. All right, and then we have intensity image. So I am showing intensity image. Always try to use tab to minimize typo error. Okay, so this is the intensity image. So each pixel is represented by the intensity, okay, itself. Like for example, 15, very dark. So if I go to very dark region, so you can see that the index, which is actually the intensity itself, is very low. If I go very bright, so we can see the index is very high, 255. Yeah, and you go somewhere which is gray, then you can see the index is actually in the middle, 150. Okay, and if you look at the RGB for gray, actually the red, green, and blue is actually the same. All right, so when RGB are same, then basically you see no color, gray, black, white. Okay, so what's next? And binary image. I am show. Okay, so binary image, basically you have either extreme dark, which is 0, or extreme bright, which is 1. I need to click exactly on that location. Yeah, so either 0 or 1. So binary image. And then last but not least, you have the RGB image, consists of 3 matrix for red, green, and blue. Right. So if you try to click let's say we try to click on the red zone. Yeah, this one. So you find that it's represented with 3 values. In this case, is floating point values, real numbers, so red, green, and blue. So it's 0 to 1. So 0.5 means it's in the middle. So the red, green, and if you look at the red, green, and blue, you'll find that in the red region, the red color intensity is the highest among the 3. And if you go to the blue region, of course, then you should expect the blue color. Okay, the third one is the highest among all. And then if you, let's say, green, then you will observe that the green is the highest, red, green, and blue. Yeah, this green color, right? So 0.3, right? So what happens if you go to white, as we say, when you come to white or black, so you can find that the red, green, and blue is actually very much the same. So bright means all RG and B is going to be very high. And for black color, all the RG and B will be close to 0. Okay, if you click on the gray, then you can see that they are very much the same. Yeah. Okay, so this red, green, and blue. And so you look at red, green, and blue, basically you have 3 matrix. All right. So far, okay, so that is what, let's go on. So, so how image represented? Either you can use a floating point real numbers in double, or it could be unsigned integer. Okay, typically 8-bit, 0 to 255. Okay, so index image could be both in double or unsigned integer. Same goes with, I think intensity, well, is either, yeah, also double, or and binary, I think only 0, 1 because it's logical. And red, green, and blue too. It could be either for real number 0 to 1, or it could be in unsigned integer 8-bit 0 to 255. Just keep this color space. Okay, so let's look at how we can import and export image. So 3 important functions here: IMF info, which will returns info about this file, and read, of course, is to read the image data, and then to write is to save the image data. Okay. Of course, you can use the user interface version, but that's beyond our discussion today, because our main focus is on using all these functions so that you could write script to do a little bit of programming. Okay, so we're going to write IMF info cano.tif. Cano.tif is actually, okay, before anything, I clear everything so that I clear my workspace and I go home. And I'm going to close this so that I'll start from fresh. And okay, so we're going to look for IMF info. Yeah, IMF info. Try tab just to make sure that, yeah, no minimize typo error. canoe.diff. Forget the single quote because we are typing the string of the file name. Okay, so you can see that when I call this function, so you can see that it listed all the important information, including what is the width of the image, height of the image, what is the precision, how many bits are there, what is the type. So this is the one that is important for your lab test later on. See, it's telling you that this canoe.tiff is an indexed image. So you need to read the map, you need to display using the map. All right. So see, by default, if you do not assign to any output, it will assign to this default ANS variable. You can double click this ANS. It's a structure, consists of many fields. So each of the field is related to one of the attributes of this image. So including the file name, width, height, color depth, and color type. So this is important for your lab test later on. Okay, please pay attention because later you need to decide how to tell whether it is an index image or not. So this is the particular field that you have to use to decide. So if it is an index image, then this field will contain a string of indexed. Okay, the string indexed. Okay. Next, so we know it's indexed. So when you read, you need to read with the map. Okay. Right. So, okay. So you can see that I read the bitmap, the image data. And if you look at it, it's actually an unsigned integer 8-bit data. And but okay, I want to show you what if you try to IM show your X now. So you're going to get something like this. So this actually what you display is the index itself. So when you display without the map, so the MATLAB will take this as an intensity image and display this as the index as the intensity. All right. So now you roughly see the outlines of the object, but it's not really what. So what happened if now you try to show with the map? So now with the map, so MATLAB will be able to decode. So it will replace each index with the corresponding RG and B, and then you get the complete image with the color. So yeah, you have to take note that you need to use map for index image. And you need to do that too if you want to save the image. So you need to IM write the X followed by the file name. So I'm going to save with canoe.bmp and then followed by the map. Sorry, it should be the map first. Followed by the file name canoe.bmp. You can see that now I have saved this, okay, but instead of TIFF now I save as BMP. So this IMWrite function is smart enough to detect your extension and then it will save according to the format of the extension. Okay, then with that you are able to actually open it using any image viewer. Okay. Maybe you can try it out. It's actually a file, image file that you could view with any viewer like Paint or Photoshop. Okay. So nothing much here. All right, so then to display image, you have IM show, which is the, or you can also use image. All right, let's skip this. Okay, next is about converting image file format. You can convert from index image to gray, or index to RGB, or gray to index, and so on. All right. And you can also convert from to binary to the double if it is unsigned integer. You can convert to double, or from double convert to unsigned integer. Okay, let's do a little bit of exercise here. So let's try to load in trees.tiff. And what type of image is it? Can you tell before loading the image? All right, so let's clear all and home. So how to tell before loading the file? So you can use IMF info, yes. Trees.tiff. Such file, trees.tiff. Let's see. Why isn't there any? Okay, let's try this thing out. Not sure whether we have the trees.tiff here. Okay, so basically consists of RGB. So basically there are 8 images in this image file. And try to what is the index? Yeah, color type index. This is an array of structure. It's not a single structure. So that means in this particular image, file consists of several images. So there are 8 images. Okay. So that's why we look for one color type. Okay. So there are 8 of them. So we are looking at the first image, which is indexed. And then we try to read with image color map. Okay. And then we try to use subplot. So why do we use sub image? Because we want to show several images. We want to show several images. Okay, and then next we do a conversion to gray, index to gray. And then we try to do subplot. So this subplot here, this refer. So this is how many rows, how many columns in one figure you want to divide to. So basically 2 means we divide into 2 rows and 2 columns. So this is the way, one of the ways for us to display several images in one figure, which we want to do so very often. And this actually indicates where. So this is number 1, the top left. Second, which is the, not mistaken, the top right. Okay, so here gray. So now we have converted this to gray and we displayed it. And we also try to convert to binary by setting a threshold 0.4. So anything above 0.4 will be set to 0, and anything below 0.4 will be set to, sorry, anything above 0.4 will be set to white, 1, and anything below will be set to 0. And this is how it looks like. It's a threshold. Okay. Right. So another one is, did you find Easter egg? So this actually is the image. So let's open up another figure and try to read. Okay, if you observe this, we actually specify we want to read the second image. All right. So if you try to display this, then you are see, this is the second image. And of course, you can read the third image if you want to. Okay, you can try it yourself. So basically, that is what I want to cover today. So we have learned on how we represent image in MATLAB as indexed, where you have a map, you need a map, and then intensity for gray, binary, black and white only, and RGB, where you have 3 matrices, one each for R, green, and red, green, and blue. And you have also seen how we make use of this, to know whether it's index image or not index image. Okay, besides knowing the other information like the width and the height, and whether it's whether it is index or non-index. And then we also see how we read and write image. So please note that to read index image, you need to read the map as well, and we will use that to do display as well. And you need to use that to write as well. And also we have seen how to convert between image file format from index to gray, or from RGB to gray, or from gray to binary. So that's basically what we have to learn today. And now let's go to your lab test. So your lab test today is you need to write a script to prompt user for file name. So then you need to read the image file, and then you must be able to read both index and non-index image. Okay, so I'll give you the hint to use the input. So you need to, okay, so this is how I'm going to work out thing. Right, so we're going to create a new script file. So this is my lab test 5. Okay, save as. Lab test 5. All right, so we're going to make use of, okay, so to do coding, okay, what you need to do is you need to first, it's just like writing an essay, you need to draft, what you're supposed to do line by line. Okay, so, so instead of typing the code, so I'm going to, write down in a human way, okay, to draft roughly what I need to do. So what I need to do is to write the script. Okay, first I need to prompt user for file name. So prompt user for file name. Yeah. Okay. So then, what I'm going to do? So this percentage sign here is meant for you to put comment or to type something which is meant for the programmers to read. Okay. Then you read the image file. Okay. So since we must be able to read both index and non-index image, okay. So then you display, okay, display image. Okay, now please take note that when you do reading the image, I'll say there are two types, one index and one non-index. So you do decide how. You need to know whether it is index or non-index image. So therefore, determine if it is index image. Okay. If yes, read image file with map. Otherwise, else. Okay. Else read image without. Same goes here. I think maybe if yes, we read and display with map, else read and display. All right, so roughly that is what our plan is all about. Okay, then so we're going to use input. So input, well, if you do not know how to use a function, you can always type and then right click and then help or press F1. It's very important for you to refer to documentation when you try to learn new software packages. So you need to know, the syntax of calling all the functions. Okay, so perhaps for me to, yeah. Okay, so two syntax here. One is to just this one with S. So display text in the prompt. So this is actually your text that you want to display user, and then wait for user to input and press return value. The user can enter expression, and right. Another one is prompt with S returns enter text as a string. So the difference is one you take it as string, another one you take it as, whatever the user can then enter expression, input value. So one is value, one is string. So in this case, because we are looking for file name, so we're going to use this format. Okay. So your prompt. So what you like to use your prompt? Your prompt is actually a text. Okay, something like please enter file name. Right. And then okay. So okay, I think we're pretty much okay with this. So in software development lifecycle, you just keep typing your code. So you type 1 line, 2 lines, and then you need to verify whether it works. So what do you expect here? So I expect, according to the documentation, so this text in the prompt, which please enter, will prompt out, and then the data entered by user will be captured as the string and then stored here. Okay, so don't forget semicolon. Okay, let's try to run it. Okay, so you see now waiting for input. So I need to, yeah. Okay, please enter image file name. So suppose I put canu.tif. Okay, so let's check. Right, so the string now captured what I have just typed canu.tif. Okay. I think the best is to clear all, so that it's always good for us to start with clear all, so that we start with a fresh workspace, clear all memory. Okay, let's try to run again. So now we are running this line here. Okay, and then it actually display the text in this variable prompt. Okay, and then so I'll type can.jpg. So you can see that it managed to capture whatever that I have typed chan.jpg and then put it in this variable string str chan.jpg. Okay, so we are ready to proceed. Next. So how do we determine whether it is index image? Yes, so you have seen in the slides that we should use IMF info. So you can use IM info, IMF info, but file name. So where is our file name? Yes, our file name is under variable string. Exactly. Okay, so I think I don't like to use this. I prefer to use the variable name should reflect what it is. str is just too general. So IMF info. Okay, so then well, let's try to run and see whether we get what we want. So I try to use the actual file name that. Okay, so you look at canu.tif. Okay, so you can see what is in IM info. So IM info. So it's actually look at this field, color type is indexed. So now how do we tell whether it is indexed? Okay. So because when it is indexed, it will contain a string indexed. So then we need to, yes, we need to use the string processing function. Yes. Yeah, I already give you the hint. You can use string compare. Okay, string compare. So if you don't know how to use it, very simple, just type it out. And then you can right click and then refer to the help. And watch. Okay, so compare two string and return one if it is true, if they're the same. Otherwise, 0. So we're going to compare the one in the field, color type, and compare and want to check whether it contains the string index. So one is the color type, another one is the string indexed. So if it is true, that means it is indexed. So we're going to compare IM info dot color type. So this is our S1. So we're going to compare with this our string. What is the how's the string like? Index. So the result is index. So I use this particular variable name representing This is a Boolean variable, true, false. So when I compare this, I'll store the result. If this is true, then the its index will be true. If not, then this will be false. Okay, so I'm going to run this and check it out whether it's true. So always do verification. So after you have one line of code, you don't just keep typing and typing. Then you will have all the errors accumulated that eventually you don't know how to solve them. That's the typical mistakes of beginners. So for programmers who have experience, usually they will keep checking their codes as they enter the new codes. Okay, so canoe.tif. So look at this. My its index is true 1. Okay, now let's try some other file. Let's say cameraman.tif. Okay, so cameraman.tif, if you look at it, it is a grayscale image. Okay, so that's why it is not indexed, and you don't need a map. So automatically this its index is 0. So that basically shows that, okay, my code is working fine. So next, this is what I'm going to do. If, so then else, and so what do you need to fill up here? I'll leave it to you to decide what to do. Okay, so if yes, you read, else you read without map. Okay, so that one, I'll leave it for you to do your exercise. I think it's quite clear now, so you can make use of what here. So it's all related to what you have created so far. So to fill up the blank here. Okay, so that is all for today. Thank you very much. See you next time.